Hello. Very quickly, I want to apologize for the last video, the last two videos cutting out shortly. I'm not quite sure why they did that. We're going to pick up where we were. Please try to watch all three videos in a series, back to back, 1, 2, and then 3, parts 1, 2, and 3. The other device I was using, I think, had filled up storage, and I just could not take any more videos. It kept shortening my range of video recordings. So, really quickly, we were 2 pi times the radius over our arc length, right? Because we were solving for, in this case, we had the radius of 0.25. We were solving for angular velocity, okay? So we had 2 pi and then we had our arc length of 0.75, okay? So this basically left us with the answer of 0.26 radians per second, okay? Because this is a velocity. So plug that in your calculator, you get 0.26 radians per second, or approximately at or about that, depending on if you round it or not. Okay, so that's that. Now, we'll have another problem where we'll have more types of problems, but as we go through, we'll do a quick acceleration one. So let's say we have a type where we have an object accelerating, right? It could be accelerating from rest, which means you just add 0 to the new acceleration, right? Or it could be accelerating from at a previous velocity, initial velocity. It can have initial velocity, okay? But in this case, the case I chose was obviously having an initial velocity. So in this case, we're gonna have initial velocity of angular velocity of 3.2 radians per second. And then we have here an acceleration of 0.21 radians per second squared. And then we have, we want to find angular velocity after 6.4 seconds. Okay, and we want to find our angular velocity. So, W. Okay, so the way we could solve for this is basically similar to how we solved the other problem, but a little bit different. In this case, we're going to use our other equation we have written down here on the previous page. We have alpha is equal to delta angular acceleration over a change in time. Okay, so delta W over delta time. So we're going to write this as alpha equals delta change in angular acceleration over a change in time. So in this case, you're given 0.21 as our acceleration, right, because it's in the units, and we're going to solve for delta W. And we have 6.4 as our time, 6.4 seconds. So we get delta W to be equal to 1.34, right, meters per second. And then what we have to do, though, is we have to account also for the 1.34 it was already moving at, right, because this machine was already moving at a velocity, was it not? It was moving at a velocity of 1.34, and now what we have to do is we have to add the 3.2 that we get from our initial velocity, okay? So this thing had an initial velocity of 3.2, okay? So W naught equals 3.2, right, meters per second, or radians per second in this case, okay? And then we add now our 1.34 radians per second. This isn't meters, this is radians per second. And then in this case, what we're going to wind up with is 4.5 radians per second as our final velocity in this case. Okay, so that's angular velocity. Now very quickly, we're going to move into another quick problem. This one's a little more complicated, okay? Here we're going to see, we want to know RPMs and we want to know linear displacement. So basically, like I said earlier, we could look at something with, we could look at things in a couple different ways. So this problem says a bicycle with a wheel of radius 0.38 meters, okay? So its radius is 0.38 meters, okay? And we have this wheel, and that's our radius, okay? And it accelerates at a constant rate of 4.8, right? So 4.8 radians per second squared is equal to our acceleration. So I write all of our givens down, right? 9.2 seconds is our time, and it's coming from rest. So therefore, B naught is equal to 0 meters per second, or 0 radians per second, rather. Okay. And then what we're going to say here is that, so we got that, and then we're going to say, they want to know how many revolutions it makes, okay? So revolutions, and we could write rev, because really R's will get confused with radius. I like to write rev, okay? We want to find a number of revolutions. We also want to find a linear displacement, okay? So we want to find our linear displacement. So we could go about this in two different, I like to go about this the first way. There's two ways